Hello, in this video we are going to talk about relationships. Let's get to it. Now, it's going to be Thanksgiving really soon, and the thing about Thanksgiving is that one of the things that we celebrate are relationships, and we can also apply that into coding. So let's actually see how we can apply it into coding. Now, these next few videos will be part of a Thanksgiving kind of theme videos. So be on the lookout for the rest of the videos for the upcoming holiday season. And the other thing is I am playing around with my lighting. This is more like a Let's Play lighting. Let me know what you think with the comments down below. So now let's go into our topic of relationships. Now, just a quick review. I actually want to review what an object is. And an object is a person, place, or thing by context. And with objects, the thing about them is that when we are talking about objects, we are referring as data as an individual object. And this actually ties in with your relationships as well. The relationship that we are going to be discussing is an object relationship. And it's more of how a object is associated with other objects. And this is more of a introduction of relationships. You can get more dynamic and also more complex with relationships. So this is much more of a broader view of object relationships. The other thing is that some of the items that I am going to show and teach you all today is going to be a little bit different of what other people might call it or what other people are going to be using for their way of explaining relationships. So just be aware that other people may call it different things online, and it does mean the exact same thing. Now you're probably wondering, why do we even need relationships in the first place? Well, realistically, if you really think about our data and the items that we're storing in our database, they're all have to do with related data, and they are related to each other, meaning that some objects might need other objects' information for it to make sense. So that's why we do need relationship, and we do need some associated data inside of our program, so our data would make a lot more sense and also easy to use. Now the next thing is going to be talking about associations. And with associations, they're a little bit different because this is how objects relate and associate to each other. And we have one-to-one association, one-to-many, many-to-many, and many-to-one. And we'll go over what each of these are. And these are the typical associations that you get with objects. And again, they go by a lot of names. And also you can get a lot more complex with these associations, but these are the main ones that you'll be looking at and probably starting off at is these associations here. So one of the associations, and the first one that we'll start off with, is a one-to-one relationship. So with a one-to-one relationship, we have one object related to another object. And that's much more better to understand if we have some examples. For example, a car has an owner. And if it really works, then it should work the other way around. So a car has an owner has a car. And that makes sense inside of our real world, because our real world, if you are an owner, you can be an owner of a single car. And a car would only have one owner. And that is an example of a one-to-one relationship. Another example would be if you're a passenger on a train or a plane, you would have a assigned seat. So with that, passenger has a single seat and a seat has an individual passenger. So that is a one-to-one relationship. And it goes that one seat is available for one passenger. So that's how you can distinguish with one-to-one, is that you only have one object related to another object and only one object. If it's not, then it might be another association. The next association is a one-to-many relationship. And this is when one object is related to other objects. And with this, you can see that customers has orders. And with this, the customer is only one customer. But orders, it could be one, it could be five, it could be 100, right? It could be many. So that's why it's a one-to-many relationship, one customer and many orders. The other example we have here is one student is enrolled to many classes. So the association here is that a single student can enroll into multiple classes for their schedule. And that's what a one-to-many relationship kind of entails, is that one object is related to the same object but multiple numeric values of that. And this one is a pretty common one. You can kind of say this as one parent with many children. Customer would be the parent and the children are the many orders that customer has. Now this would be a many-to-many relationship. This is where things will get a little bit more complex. The reason being is that when we have a many-to-many relationship, objects are related to other objects and many forms of that object on both sides of the relationship. For example, you can go back and forth between the data. So this is how books has many authors, and many books can have many authors, and then many authors have many books. So then that would be a many-to-many relationship, because both of those could be multiple values, right? You can have Dr. Seuss with the book of Green Eggs and Ham, Cat in the Hat, and maybe like a co-author of like Dr. Seuss, I guess, of like the Cat in the Hat and Green Eggs and Ham. So you can have a many-to-many relationship there. The next example would make a lot more sense. You have cars to parts and then parts to cars. And this is a many-to-many relationship because you can have many cars have many parts, right? So for example, if you have a Toyota and it needs like a muffler, then there might be like different types of muffler for that single Toyota. But again, Toyota is just a particular car make, right? You need to have a model like Toyota Prius, Camry, etc. Those will all have different parts as well as different cars. So that's why this is a many-to-many relationship. And typically, if you want a many-to-many relationship, it kind of goes with multiple objects going to multiple objects. And with this way, in most cases, you're able to bring the object information back and forth. What I mean by that is that you can grab the parts information and the cars information all from the parts method or all from the parts class. But in our previous example, like if it's a one-to-many, the customer has the ability to grab all of the orders, and then the order is only available to get all of the customer. If we want to get more details or other customers, then we don't have access to that for the one-to-many. But this way, it makes more sense for us to have the ability to get in touch with multiple cars and multiple parts. The other thing is that it might be a polymorphic solution. And what I mean by that is that, as you remember, polymorphic means that it can take on many forms. And this is when a single object takes on multiple forms. For example, we have a user's model and it is related to itself. That doesn't make sense unless it has different roles, right? We have like the employee user and the customer user. With the employee user and the customer user, they're still technically users, but it has a relationship to itself. The reason being is that the employee can have many customers, and then customer can have a single employee or many employees that help that customer. So that's why this would be another way that you can do a many-to-many relationship. The last one is the many-to-one association, and this one is kind of the inverse of the one-to-many relationship. It's just depending on how you look at it, on which side it is that you're looking at. It might be a many-to-one or one-to-many. For example, we have here employees work at a single store. That is a many-to-one. All of the many employees work at the store. And the next example is many devs worked on a single project. And with this, you have multiple developers working on a single project. And you could say it the other way around, but if that's the case, then it will be one-to-many. For example, one project has many developers. That is a one-to-many example association. So those are all the associations that you might be dealing with objects. Now, with the relationship, it could be different types of relationship of how data is related to each other. It might be a parent to child relationship. It might be like a has many. So a customer has many orders. It could be polymorphic, where it's related and associated with itself. It could belong to something, or it has one of. So those are attributes and relationships that objects can have with each other. And then how they're associated with each other, those are different as well. So associations and relationships, they are very similar, but they're a little bit different here and there. And you might be still confused about these different types of relationships and different types of associations. So I have some questions here that may help you decide whether or not your objects would need a relationship or not, because oftentimes you may not even need a relationship at all. So the first question is that, does this object need a relationship? And that should be a yes or no question. If you're saying that maybe or it might later on, try to see what the relationship or what table or object is related to. So that is a question you can ask yourself if it does need a relationship or not. Now, if you answer yes to the last question, then the next question you should ask is, do you have information or data that is dependent or associated or used between two objects? Because this will tell you if you need a relationship or association as well. And what I mean by this is that, do you need information from another object? For example, if you have a student and student has a address object, you can see that we can just have the address object by itself just because we don't know who address that belongs to, right? So that's why we need it to be related to a student. That way we know the address belongs to a particular student. So with that case, that would be yes. Let's say that I have a address object and a phone object. Those don't really relate to each other because the data that it has doesn't really associate with each other. So that one, for example, would be a no. And if I say table here and there, that might be your database tables, or it might be an object, or it might be a individual item that you're using. So it could apply to your database or object relationships, inheritance, etc. Now, if you answer yes to any of those past questions, that means that you probably have a relationship. And with these relationships, you need to find out what kind of relationship it is, because it does go both ways. For example, for the address and student, the address belongs to a student, and then a student has one address, for example. That would be a kind of relationship that it has. And it should make sense when you read it out loud. If I say that a student belongs to address and address has many student, that doesn't make sense in most cases. That won't work inside of the project because you don't know what students our address is associated with. So a better relationship should make sense when you're reading it out loud. And again, this actually just takes practice as well as a lot of thinking and planning out. So just see if it not only makes sense for you, but also for other people, if that makes sense of what kind of relationship objects have with each other. And I would definitely practice this because it does come up a lot inside of your project, inside of your planning as well. That is all for what I have today with relationships. If you like it, please leave a comment down below, press like, and share the video. I'll see you in the next video.